of an email content. So this has got application layer header and also the content. The content in this is actually a packet taken from the email communication. So hello world is the, everybody can see this, hello world. In the middle at the bottom just as well is the content that is going in the email. And you can see a lot of other content in the top. 220, hello mayank.iti.ac.in, 250, mx.google.com, service, mail from, so and so forth, and what. So this is all from this 220 to till from mayank@example.com, and just above the line hello world is all the control application layer control information. So this is how the mail transfer protocol SMTP actually works. So it has got a set of keywords and each message is numbered. 220 carries some meaning, 250 carries some meaning, and who is the sender, mail from mayank@example.com. So who is the recipient, which is 2nikhil3.684@gmail.com. What is the subject line? This is the subject line. These are all the typical content that goes in SMTP communication or email communication. By the way, SMTP means the mail transfer protocol. So the standard structure actually helps us to identify this packet which is carrying so and so content is actually of the email traffic. So what we essentially do is you take these keywords hello, recipient, to, and who is the from received by so and so email. So to receive to. So these are all from messages or the very standard messages in an email header. So we make use of all these keywords and build some kind of the signature, and any packet which is having these many keywords are identified as an SMTP protocol or an email content. So once I identify that, then I can do whatever I want, whether I want to permit that packet to go through or I want to block it at a certain point of time, or want to assign lower priority for transmission, higher priority for transmission, whatever my network administrator want to do it, he can do it. So in order to do all of this, the fundamental thing is you need to do this classification very accurately. So if you make a mistake in classification, whatever the inference you want to draw will also be wrong. So I'll give an example. So for example, if I want to drop or don't allow Facebook content to go through to my network, and if I wrongly identify an audio video content as a Facebook message, experience goes down. So this should not happen. So in order to achieve the right so you need to do the classification very, very accurately. If you make a mistake, then inference will also be wrong. So this traffic classification is primarily used by internet service providers. Normally at the end user premises like institutes and the example that I took, they're also do sometimes, but there are built-in applications they normally run with the default settings. But from a network service providers perspective like BSNL, Airtel and the other service providers, this is a very, very critical task. They do this traffic classification quite extensively to provide something called quality of service. So here is a picture that shows two diagrams. The one which is having the bandwidth with the no quality of service rule applied. The second one is with some quality of service applied. So if I have a mixture of traffic like video, audio streaming, and a bunch of people are using the internet for browsing and doing their system updates and chatting, so forth, and the third application is somebody is playing the game, all of the content, the audio video content, the web browsing HTTP content, the file transfer content, somebody is downloading the movie through a torrent, somebody is playing an online game, everything car, and somebody is playing music, somebody is watching a movie, somebody is sending an email, somebody is doing so many other things, mobile applications. So if lot of users suddenly start playing the game using the network, and if somebody like me and some of you are listening to me in the session, so your quality of service, audio, video might break down because the online video game will eat up lot of bandwidth, then your quality of service goes down. So you will not be able to hear me, and just like you were a while ago, you were complaining, Professor Anwar Sharma's audio you are not able to hear. So similar things happen. So in order to ensure that such things don't happen, so what the service providers or the network administrators typically do is identify which packet is of the audio, video, which packet is of online gaming, then I can curtail. So maybe I don't want the online gamers to hog the network, so I'll give a low priority of transmission to the online gamers, but give a seamless and continuous transmission to the video audio transmission, because that is sensitive to the delay and jitter and so forth. The reconstruction of the audio at the recipient end will not be smooth. So that is what typically quality of service means. So first you identify which packet is of which application, and based on that, with certain priority, you allow that packet to transmit, exit your network and back. So this is another application which is a very real-time and practical application where deep packet inspection is used. So in order to do this curtailing business, I need to do the accurate classification or identification of the application. So if I make a mistake, then
मैं भी देखा तो बोल रहा सर बोल दीजिए, उसमें तो मैंने पूरा डिटेल किया है.
So somebody has a question. I hear a audio in the background.
ए भगवान.
Okay, I hope is all right. I'll continue. Okay. So how do you do the against? So there are a number of ways you can do that, but first let's see a couple of other applications used. Another typical application where deep packet inspection is used is something called network intrusion detection system, and so you basically identify whether there is some malicious content going in your network. I'll give a few examples in a moment of time, but to begin with, there are. So this is how typically network-based intrusion detection system works. So you collect some network traffic at a choke point, again at the gateway. There are some appliances which are built, and you extract the payload from each of the packet that is going in and out of your network, do a rule matching, and classify them either as the malicious or non-malicious content. If it is non-malicious, you permit it to go through. If it is identified as malicious, then you drop the packet. So this is what typically in intrusion detection system goes. There is a thin line difference between a term called intrusion detection and intrusion prevention, but in general, the whatever appliances that are built by security companies like Cisco and companies are actually they build with the intrusion prevention capabilities. So that's why they come with the ability to block or drop the packets. So technically speaking, intrusion detection essentially means you just detect it, don't do anything. Intrusion prevention system can do the detection and also the block content. So there are two ways of doing this. One is called signature-based intrusion detection, where you have a set of rules defined and stored in a database, and as and when the network traffic you observe at a choke point like a gateway, you take that packet and to sequentially match with all the signatures that are in the database. And the second approach of doing it is something called anomaly detection, where I don't have anything signature for the known malicious content, but have a model of what the normal should look like. So anything that deviates from the normal will be detected as malicious. We'll see in a minute with the, like what all. So a network-based intrusion detection system typically might look like this. So your NIDS sensor is the gateway, and you have a signature database deployed, and network packets come, and so you mask the traffic with the signatures, and then you log some of the content, whatever we call as the alert. So and so thing happened in the network at so and so time. So how does the rule such matching look like? So here is an example of an IDS intrusion detection system rule. So what it says is alert whenever a user tries to access the slash pi. So slash is this password. If anybody of you have used Linux system, this is where the username and the passwords are stored. In the password file, you don't have usually the password. There is something called shadow file, but typically this is what it means. So think of this situation. You are sitting inside your campus. I am outside your network, and I have got a remote access to one of the computer in your network. So I log in. So typically you don't expect me to access the slash etc password of the computer that you give me access. So how do I detect? If you are a system administrator, you want to monitor whether I am accessing a slash etc password file on the system that you give access. So here is a sample rule, which is the SNOT syntax rule. SNOT is an open source IDS engine. So here is a reference for www.snot.org. You can go and actually download and for it. So what this rule is actually saying is alert, generate an alert when the connection is I'm referring to the two lines which are in the red line. Alert TCP when the packet is of the type TCP and the packet is coming from any external network. This is a variable which defines what it means by external network. So if I use some IP address range in my network, in your ICE network, academy network, and anything other than what the IP address range used in your network becomes the external IP address. I can actually define what exactly is I can typically define only one IP address series. From this series is an external network. I can also define, so anything other than my own network, what is being used is the external network. So any packet which is of the TCP and coming from an external IP address from any port number, going to any computer in my network, this arrow mark is what is next to that is the computer which is inside my network. The external network can be an IP address. It can be a summary enumeration of a bunch of IP address, and going to any computer in your network, going on any port number, and what it should carry is that packet should have the content slash etc slash password, and if that's the case, you log that alert with a message password access attempt being done from so and so IP address. And there are a couple of numbers here. This is SID 1000004 and one something like that. This actually means that SID means signature ID. So when I see an alert message being written into a log file, I actually want to see which signature actually generated this message. So every signature has got a number, has got an ID. So I can match this alert triggered. So match the signature and the alert for a system administrator's perspective. This number is written. So revision means which version of the signature. You can have multiple versions of the same signature. So barring these two numbers, this essentially means that any packet that is carrying slash etc slash password as a content in it and coming from an external network, if the packet is of TCP type, you should write a message to so this is how the intrusion detection system work. So what it actually internally boils down is, so you are actually looking for a content slash etc slash password inside the network packet. So it boils down to a string matching problem. I'll come to that in a while. So most of the open source IDS engines like Snort and Zeek and the almost all commercial intrusion detection systems. Here I've written a couple of examples. HP, Tipping Point, Cisco networking appliances use something called regular expression based signature matching. So I'll give an example of this. So what is written here, content is the actual content to be served, slash etc slash password is the exact string to be matched. This is not a regular expression. Here is an example which is having a regular expression. So alert TCP, again coming a packet coming from external network, coming from having any port number, going to one IP address having with 192.168.3.0. This is an internal IP address on a slash 24 IP address. So it is going to any of the inside system which is having this IP address series, going on port number 80 and using the rule, this is PCRE, means parallel compatible regular expression, having the content get dot star HTML, you should have the sample alert is matched. That is what it means. This is just a strict example. So what I'm searching here is using the parallel compatible regular expression. PCRE means that. So I'm searching for a content which is a slash get, then a dot, and then I don't bother what is there. At the end, I should have an HTML. So anything that is having a content get followed by some name and followed by an HTML should be generating an alert. So here is another example. Alert TCP external network, any coming from any network going to the HTTP servers. I can define where running in my network. The message should be printed is web attacks or CC command attempt. This is the message is actually the content that is printed on the alert that is generated. So here it has a couple of more parameter. Flow is established to a server, meaning that so every time you access a web page, there is a flow that is generated, flow of packets from your computer to the server, and that session is actually in a state it is established, and the packet carrying the content CC %20. It doesn't matter whether it is the no case, uppercase or lowercase. That is what no case means, and the what type of attack it is, web application attack, and similarly we have a signature ID and the revision version. So let's go and look into how this packet searching, deep packet inspection is used with respect to this rule. So I'm actually looking for the content CC %20. This is basically I'm looking for an attack in a web content. If somebody is trying to compile a C program, so it essentially means that somebody has got a cell access on your computer where your HTTP servers are deployed. So what it means is this means that every packet has got these many headers, as we saw in the beginning: link layer header, network layer, transport layer header, and then a payload. So I put some random payload content here like ABC, 5H, ETI, whatever it is going. So you begin searching from the first, you take these 5 bytes of the CC %20, and you put go in that, put that in a sliding window, take every 5 bytes in the payload, and then find whether this is CC %20. If this is not CC %20, then you slide the window by 1 more byte in the payload, and then see whether this is CC %20. You keep doing this, slide 1 byte at a time, and then you keep on moving till either you find a CC percentage 20 or you hit the end of the payload. So either one of them. So in this example payload random content that I have put, there is a CC percentage 20 highlighted in the last diagram. CC percentage 20 is there. So it's, you typically do a searching operation from the beginning of the payload till the end of the payload. So I don't know in which of the packet CC percentage 20 appears. If my session has got 100 packets, so from every packet payload, I need to keep searching whether CC percentage 20 is appearing in the packets. So number of the comparisons in one packet is equal to the payload length. If I have 1000 bytes payload minus the keyword length, here in this case the 5 byte payload pattern is there. So these mean number of comparisons we need to do. So 1000 minus 5, that essentially 995. 995 number of 5 byte comparisons on one packet payload. That is how typically the searching operation will take place. So you can see this is actually a lot of work to do. 995 comparisons per packet. If I have thousands of packets or millions of packets, from every packet, these many number of comparisons is actually very, very expensive to do. And if you have thousands of rules, given a packet, every packet payload need to be evaluated against the every rule that is there in the database. Thousands of rules, one packet, thousands of bytes of the data, and for every pattern, for every rule, you have a large set of string matching operations to do. So that's actually a lot of work to do. So given today's network speed, it's actually very, very in real time doing. If you do a bad job at the signature matching, at the string matching, then your network performance will actually go down. So user experience will down. So that's actually we don't want. We want to do a string matching algorithm operation in real time without hurting the speed of the end users. The bandwidth experienced by end users should not go down. That is the critical aspect of this deep packet inspection. So this is one aspect where you want to detect the attacks that are coming from external sources to your network. You want to identify them. That is where deep packet inspection is used. And that essentially is again string matching problem. So there are other applications like content filtering. So for an example, if somebody is accessing adult content from your network and the system administrator doesn't want them to do the give access to that, so again we use deep packet inspection to see whether what kind of URL names are going and what kind of content is actually going inside the packets, and if you see anything which is not appropriate, you can actually block that content from being accessed. So this is typically done contents like child pornography, which is spread in the internet by deep packet inspection is used. And there are some commercial solutions like MakeCafe's Smart Filter, WebSense, and etc. They actually do this kind of filtering using deep packet inspection. So the last application that I want to talk about is called targeted advertisement. Here is a screenshot. I type a content called ThinkPad, and you can see in the search result the top one is called something related to the ThinkPad, which is Lenovo.com. Explore all the new ThinkPad, something it is showing, Google is showing. Google actually doesn't do deep packet inspection to show this advertisement because they have the content, but think of an intermediate. So, for example, sometimes these internet service providers themselves push some advertisement to as a response to your search queries. So if that is the case, they actually need to do using deep packet inspection, identify what I'm searching for, and then do the throw the relevant advertisement to my screen. So this is where deep packet inspection is typically used. So you use it in, let me summarize, you use it in traffic classification where you want to identify given a set of packets to which applications actually generated that traffic or packet. You use it in web traffic control like pornographic adult content. You use it in intrusion detection system to identify whether malicious attacks are coming to my network. Use it in quality of service where I want to give better preference to some of the audio video content than the gaming applications, or I want to block certain content being used in my network. You use it in targeted advertisement and so forth. This is the typical landscape, something to do with the network security. This deep packet inspection is actually used. And there are some negative applications of critics of the deep packet inspection. The fundamental critics of the deep packet inspection is that it compromises user privacy. So if I see what all content goes in the packet, I actually so think of this situation. If I'm chatting with somebody, or like I'm talking to all of you, if somebody who has nothing to do with this session is sitting in the middle and listening to our conversation, or if two people are chatting in a private chat box and somebody else in the middle is able to do, because I got a deep packet inspection ability, even the network administrators themselves are able to see the content of what is we are exchanging is actually intrusive to our privacy. This is the drawback of the deep packet inspection. And it is also against the net neutrality. Net neutrality essentially says that irrespective of what kind of content being accessed, as long as I pay for my bandwidth, I should be able to transmit all the traffic. So, but the downside of this is, so if every content is allowed to use it, there are a set of users like online gamers who actually hog the network without leaving any bandwidth for anyone else to use. So in practice, net neutrality is a nice thing to have, but from a service provider's perspective, like BSNL and Airtel, it's not actually easy if you follow the net neutrality. So there are other aspects like Chinese governments are known
Sir,
to.
please share PPT.
Sorry.
Sir, please share PPT, sir.
Okay. Oh, it is. Okay. Is it visible now? Hello.
Yes, sir.
Yes, sir, it is visible.
Visible, sir.
Yeah, yeah. So it compromises deep packet inspection actually compromises user privacy. It is against the net neutrality because I'm differentiating by doing the inspection of the packet. I'm giving preference to audio video content than the other video game content. That is against the net neutrality. And there are again state governments like Chinese governments which have built a nationwide very big firewalls which do the deep packet inspection. So they don't allow any content being accessed from inside their country which is against their own government. If somebody, let's say, I sit and write some content against the Chinese government, and if somebody inside the China visit that website, they actually screen what kind of content is actually being accessed by their own citizens. If it is something to do with their own government, and they might actually block that. There are a lot of studies done how the firewall with several thousands of servers which screen the traffic in real time and do the this kind of the censorship, which is again not advisable to some sense. So let's not get into that political aspect of this one. But what I mean to say is, so deep packet inspection compromises use of privacy. It also can sometimes be used by government agencies to censor what the users actually see. Even if I am able to curtail the and depreciating and transmitting content to giving preference of one kind of content over the other, I am actually violating the net neutrality. That's the negative side of the DPA. But in fact, in spite of all of this, and several governments across the world, the globe, have passed the resolutions for the ISPs to follow net neutrality, but in practice, they are not followed 100% even as of today. So that's the state of art. So let's now go and look into some algorithmic aspects of how this deep packet inspection. We understood what is deep packet inspection, and we understand what are the applications, why we want to do that. Now let's see how in practice this is done. There are two aspects doing this. One is called the protocol decoding, another one is pattern matching. So pattern matching is basically a string matching problem, and then you can also have a regular expression matching. For example, the one example that I showed. So protocol decoding is basically custom built application decoder. So for example, I'll see one content. So for example, this is a payload of the SMTP application. I build custom parsers specific to SMTP payload itself. So for example, looking at the structure, which hello should come first, and subsequently what should come next, and how big that is, and I encode such kind of rule. HELO should come first, that is hello, and the second line 250, and then the main from should come next, and then what order these keywords are appearing in the payload. I build such kind of the parsers, and particular to that application itself. So I want to monitor SMTP topic itself. I build one parser, and it can identify only SMTP payload itself. That is one way of doing the parsing. This is the application decoding parsing, and it uses application specific, protocol specific parsers, and sometimes these protocols are standardized. So for example, SMTP is a standard protocol. There are standard RFCs defined by IETF. You can go and refer how an SMTP traffic application header look like, what should be exchanged between them. So for example, to in an email message is standardized. There are some applications which are called proprietary application. These are not open source, so I cannot know. So I'll give an example. So if I use the, for example, this WebEx by Cisco goes how the communication is engineered, what kind of messages go between the speaker and the recipient, and what protocol is being used, and what is the header, and all of that. So we use Skype as the proprietary protocol used. So we don't have proper open source documents which specify what exactly and goes beneath that, and how the messages of these protocol look like. If that's the case, then what I can do is I can take a bunch of packets belonging to Skype or WebEx, and then do a reverse engineering, dissect and see what exactly is there. So then I can make out bit by bit what exactly is transmitted, and then I can come up with some kind of the application parts that's built to put that. Provided it is not openly spelled out. So if it is a standardized public protocol, then you can straight away build an application parser. If it is a proprietary protocol like Skype and WebEx and the other protocols, you can actually do reverse engineering and then try to build some kind of parser to that. So this is one. So second is we extensively use when in the deep packet inspection string matching algorithms. So what let's take a look this simple example. I have some string which I am calling as an S. A, B, C, D, E, F, G, H, I, J is the content. Think of this as the payload within a packet. And what I want to search is a pattern of CDE within this string. So I'm having a payload of a packet, that is my S, extracted from a packet, and then I have a rule which is saying you should search for CDE. Then the typical search is actually I take the CDE and put the 3-byte window on the S and see whether this is CDE. This is not a CDE. Then slide the window by 1 byte and see whether this is CDE. This is not a CDE. It fails. And then the third attempt, when the window slides by 1 more byte, you actually hit match. So CD is actually present in this text. Then you declare that it is actually a successful match. So that is how typically string searching algorithms work. This is a name search algorithm. So algorithmically, if you look at any string matching algorithm have two things. One is yes, that is the string to be matched, which in the deep packet inspection case is the payload of the packet, and then the P is a pattern which is the coming from the signatures which are up in this format. So basically here in this /etc/password is a keyword. So I take the keyword in this rule and then it actually translates to this kind of the string matching problem. So I keep this. So from you identify what is the length of the string and what is the length of the pattern P to be matched. From S is equal to 0 to length of n minus m, you keep incrementing the S. I and j are initialized to 1, and as long as j is less than or equal to m and p of s plus I is matching to the p of j, then you increment I plus j plus 1. This is typically this. If the first letter byte of the pattern and this one is matching, then you continue the next one. So if the first letter itself of the pattern doesn't match, there is no point in continuing the remaining bytes. So think of this. I have a 10 byte pattern. Here in this case is a 3 byte. If the first letter itself is not a C, then there is no point in matching the remaining 2 letters. Then I can just skip by the other 2 buttons. Everybody with me? So I want to search, given S, I want to search this pattern CDE. I take this and go and compare A with C and B with D and C with E. So what I'm saying is, if A and C, A of the string and C of the pattern are point in matching with B and D and C and E. So that is a wasteful comparison. I avoid comparing them. So I can skip some of those comparisons. So that's the optimization. The algorithm is actually doing that. If j is less than or equal to m, so m is the length of the pattern. I don't go beyond the length of the pattern. And then if the t of s plus I, where I am searching, is equal to p of j, then only increment it and then keep moving toward the next byte. So if any of the pattern letter is not matching, so for example, if first letter is C, if the second letter is not a D, then there is no point in matching the third letter. So as long as I find a match for the characters which are sequencing in this pattern, C is matched, D is matched, generally match E. See, if C is not matched, then you skip D and D. So like those characters in the strings. So wherever they are not matching, you just skip the remaining characters and slide the window by 1 more byte. So at the end of this, if j is at the size m plus 1, because you are incrementing j also as long as the characters are matching, and I also incrementing as long as the characters are matching, and then at the m plus 1 point, if j is residing, then the pattern is found. So if you look at this algorithm, the complexity of this algorithm is n cross m because there are two loops. One is outer loop S is varying from 0 to the length of the n. So S is less than or equal to n minus m. The inside loop is varying from from j is less than or equal to m while j is less than or equal to m. So from 1 to m. So outside S is varying from 0 to m and j is varying from 1 to m. So that means that it is n cross m complexity. So you can do slightly asymptotically, this is what it is, slightly better than this. So one of the simple algorithm which improves the computational complexity of such a string matching algorithm is called Robin-Karp algorithm. So what it does is it does a simple modification to the string matching problem. So I am given for this function Robin-Karp a string S which is of length n, which is the same string which is of length n, and then a pattern P which is of length 1 to m. So what I do is I take that pattern and hash that pattern. So in this case, my pattern is CDE. I pass this CDE to a hash function. So I generate a hash of that CDE. So I presume everybody knows what is a hash function. Okay. So what is the mixture of the ideas? I forgot to ask. Is it only computer science students or anybody? Another?
Yes, sir.
Of those students are from computer science department, sir. And faculty member also.
Okay. So let me. The hash function is a function which takes some input and generates a fixed sized output. Document. When I compute the 1000-page document, I get a fixed length output. So, for example, the MD5, if you heard the name, is a hash function that generates typically maybe 256-bit length output. So, irrespective of the size of the input, it generates 256 byte output. What is the size of the output is fixed. So, whether the input is lesser than the 256 or greater than the 256, an arbitrary size input length is mapped to a fixed length output, which in this case is a 256 byte. So you can have a smaller number as well. So you can generate only 1 byte output. It depends upon the hash algorithm. So what this Robin-Karp algorithm does is first compute the hash of the pattern. So assuming CD is the hash of the CD is the pattern to be searched, you give CD as the input. It generates a 1 byte hash value, which is my H pattern, and then you take every 3 byte data from the string, which is from the S, and then compute the hash of the those 3 bytes. So in this case, the string is ABCD of GHIJ. I take first 3 bytes ABC, compute the hash of this ABC as an input, and compare the hash of the ABC with the hash of the CDE, which is already computed. And if the hash two hashes match, then you go and do a full-fledged byte by byte comparison. So if the hashes match, then there is a strong reason to believe that ABCD is found in the place. So you keep doing this. So first take the first 3 bytes, generate the hash, compare that hash with the hash of the pattern, take the next 3 bytes BCD, compute the hash, and compare that hash with the hash of the CDE, and so forth. This is what this algorithm is doing. H pattern is the hash of the pattern that is CDE computed once, and then I take every 3 bytes I plus m minus 1, that's the length of the pattern is m, and then I take all the bytes within that pattern length. I take 3 bytes from that input string, compute the hash, that is my HS. What I do is, if HS is equal to H pattern is the hash of the pattern, then I do a full plus VS of I compare I every 3 bytes from the pattern from the. So if you use this algorithm, the computational complexity of this algorithm is linear, meaning that order of n plus m. Given that pattern length is very small, which in this case CDE, and the n is very large, typically if you take the network of 10, this is actually of the from 200 to maximum, if you take the Ethernet case, it is 1500 bytes. So rather than going having a new algorithm which is giving n cross m complexity, which is expensive to do. So think of this 1500 bytes of the data, and then multiplying that with the 3 bytes of data is the number of comparisons would be 1500 times 3, which is 4500 number of comparisons. But in this case, it is a linear n plus m. So 1500 plus the size of the pattern, which is 3. So it's actually 1500 plus 3. That's actually much better than the previous one. That is what the Rabinkov algorithm actually does. So there are such nice algorithms which do multiple such optimizations. Skipping comparisons and generating hashes to improve the computational speed of this string matching, which is actually used in the defect inspection. So that is typically what happens beneath the pattern matching. So there are other algorithms which is another practically used algorithm. Scientists which invented this algorithm, their first name is taken, and that algorithm is actually first letter of their name is taken. It is called KMP. It is actually linear time algorithm. So what it does is it does simple improvement over the
Hello? Hello?
is the total alphabet set minus C is the character. So you actually be there in the state Q0. So you read any other character other than C, then the self loop will take you back from Q0 to Q0 itself. On the input C, you transit from Q0 to Q1, and input C being at a Q1 is actually at the Q1. So any string which is having, let's say, 4 number of the C's continuously and then followed by a D and D, you actually find a CD is active. That is why this cell. So you can visualize, so anything other than D and C from the state Q0 will bring you back to the state Q0. It means that you still need to, that string CDE, whatever you wanted to search is actually broken. So like this, such an automaton is built, and the appropriately states are and the transitions are labeled, and you move between one state to another state and then see whether pattern CD is found. So how does this is a visual representation of the state transition machine, a finite automata. And in terms of the computer representation, you can actually store this state transition machine as a matrix where you have as many rows, as many number of the states, and as many columns, as many number of the states. So in this case, I have 4 states, and then the matrix would be a 4 cross 4 matrix. So an entry in this any row and column is actually the transition that is there. So from Q0 to Q1 is actually sigma minus C. So I encode that here, put that here. any character other than C in the sigma, so you need to go from Q0 to Q1. So in this case, the row is Q0. When the machine is in the state Q0, the next state would be, if you read any character other than C, would be Q0, which is indicated by the column. Similarly, when you read a character C, Q0 is taking you to the state Q1, so that is indicated by the first row and this third column, Q0 to Q1 with an input C. So like this, all the transitions and the states are encoded in the form of a matrix. You can consult this matrix to find out where the machine is in the current state. So at any point of time, if the machine happens to be in the final state, is actually the pattern you are searching for is found. So remember, such tables need to be built for every pattern that is there in the signature, every signature. So one signature, one pattern, one table. Sometimes signature might have more than one pattern, so you need to have more than one table. So you essentially require large storage space to store these patterns itself and keep identifying which pattern belongs to which of the signature. There is actually again lot of work to do. So that is typically what happens inside the computer when you do a deep packet inspection. So nevertheless, given that automaton-based things are extensively used and matrix-based state transition machine, the reason why they are popular is they give a deterministic execution time guarantee. So if I have a string length of n, which is an input string, so at the maximum number of the character that I read is n. So in n characters, I either find the pattern, I don't find, I conclude that the pattern is not found in the input string. So unlike the Decoding algorithm, which is n cross n, this state transition based tracking will give you a linear time guarantee that within the order of n time we will be able to either find the string and correlation, which is independent of the size of the input there. So that is the advantage with the deterministic finite automata based string matching or deep packet inspection. So, but the DFAs have another problem called state exclusion problem, but let's not go into details of that. But this is typically what happens inside the string matching inside the computer. So we have been at IIT Indore doing some work related to deep packet inspection with some of my PhD students and undergraduate students. So our work at is we want to do deep packet inspection faster. That is the accelerating deep packet inspection. And the second thing is improving the accuracy of deep packet inspection methods for topic classification application. So we did a few works. I am going to talk about a couple of them here. Some of the RD class, bit coding, and bit code. Let's go and see what exactly we have been doing at IIT Indore. So we have been working on traffic classification. Typically, without actually going into the deep packet inspection, let's see how typically deep traffic classification is done. Earlier, traffic classification was done using the port numbers, because specific applications use specific port numbers. Like if you take the SMTP, its port number is 25. If you take the HTTP, port number is 80. So any packet that uses port number 80 is classified as HTTP. Any port number packet which sent on the port number 25 is automatically classified as 25 and so forth. But this method of identifying the traffic or traffic classification is no longer reliable, because a lot of non-standard tunneling. So if in my network, so what Facebook can do is essentially use the port number 80 and send it, use a different IP address than where it is supposed to go, and then transmit the packet. So since I coordinate to the packet with the port number 80, then this packet also goes, which actually has something else inside it other than the HTTP traffic. So then in that case, this method will fail. So being inspecting only the port number. So the two applications actually knows how to reconstruct the what is going on between them, and the port number 80 is being outside as the outsider. So if I use blocking or allowing using only port number, that's not going to work out. And there are some bunch of machine learning algorithms being used with the flow characteristics to identifying the traffic, but none of these are actually are used in practice. Most of them are academic research, restricted to academic research. So, but unlike these two, deep packet instruction is practically used. You buy any appliance from any vendor today, so they do use deep packet inspection for doing the traffic classification. But as I told, these are computationally expensive. You need to handle large packet with large speed, millions of packets per second with Gbps bandwidth. And so you need to have large computational power to do this deep packet inspection. Essentially, I need the capability to do large number of string comparisons at the line speed. So that's what I'm looking for. That is why doing the accelerating the deep packet inspection is an important thing to do. So here is a packet, HTTP packet, and a rule, you think of this, every HTTP packet is actually going starting with the keyword get. So if you look at any time you use the Wireshark and seen the HTTP traffic, when I say google.com, www.google.com, there is an HTTP request goes. That HTTP request is actually having a keyword called get HTTP 1.1, so on, host, connection, so forth, to something else there. So this can serve as an indicator that I'm actually searching for some or browsing some HTTP content from my web browser. So it essentially boils into identifying that keyword get followed by something HTTP, something followed by .com, something followed by .org together. But we can see that get, and in between that HTTP, the version number 1.1, 1.2, whatever it is, and then the actual URL name xyz.com is actually something else. They are interleaved in some fashion. So starting is get, and then the HTTP, then the version number, then the URL name, and that is ending with .org.com together constitute a signature, which essentially tells me or gives confidence to me that whatever I am browsing or the packet that is inspecting is actually an HTTP packet. So that's a regular expression based something else.
Screen application. Okay. 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 So मेरी स्क्रीन विजिबल है क्या आप लोगों को?
Yes, sir, it's visible.
Yes.
Okay.
Yes, sir.
Thank you so much. ठीक है, जो लोग स्पीकर और माइक दोनों यूज कर रहे हैं वो माइक म्यूट ही रखें तो अच्छा है. अभी काफी कम हो गया है नॉइस. सो जो आज सेशन है, दिस सेशन इज ऑन डेटा प्रोटेक्शन एंड साइबर सिक्योरिटी, एंड आई कैन अंडरस्टैंड कि आई एम द थर्ड स्पीकर. सो थर्ड स्पीकर मतलब काफी चीजें, बहुत सारे लोगों ने मेरे से पहले काफी सारी इंफॉर्मेशन शेयर की होंगी. सो मेरी कोशिश तो रही है कि मैं कंटेंट थोड़ा सा यूनिक बनाऊं, लेकिन अगर कुछ मिक्स होता है या मेरे को नहीं पता, क्योंकि मैं पुराने स्पीकर का सेशन अटेंड नहीं कर पाया था तो वहाँ क्या इन्फॉर्मेशन शेयर हुई थी, तो अगर कुछ कंटेंट रिपीट होता तो उसके लिए मैं माफी चाहूंगा पहले से ही. जैसा कि सर ने बताया, मैं आईआईटी बॉम्बे से सर्टिफाइड एथिकल हैकर हूँ, और आईआईटी खड़गपुर के प्रोफेसर्स को मैंने क्लाउड पढ़ाया हुआ है. आप लोग जो एनपीटेल का एग्जाम देते हैं, एनपीटेल के एग्जाम है पूरा वो हमारे क्लाउड इंफ्रास्ट्रक्चर पे चलता है, जो खड़गपुर में हमने सेट किया हुआ है बेसिकली। तो क्लाउड मेरा एक्सपर्टीज पार्ट है, एडब्ल्यूएस सर्टिफाइड आर्किटेक्ट एसोसिएट हूँ, इंडियन आर्मी को रेगुलर हर साल ट्रेनिंग देता हूँ मैं। तो ये ढेर सारी फील्ड है जहाँ पे मैं पढ़ाने का काम करता हूँ। तो स्टार्ट करते हैं अपन क्लास सीधे। सो यहाँ सबसे पहले मैंने डिस्क्लेमर दिया आपको कि आई एम नॉट हियर टू टॉक विथ यू ऑन हैकिंग। सो हैकिंग मैंने अपने जीवन की सबसे पहली हैकिंग 1999 में की थी, मतलब ऑलमोस्ट इट्स 21 ईयर्स। लेकिन वो हैकिंग करने के बाद मेरे को समझ में आया कि मैंने गलत काम कर दिया। अगर गलती से किसी ने इस बात को ट्रेस कर लिया कि ये काम मैंने किया है, तो मैं तब 18 साल का था, मेरा तो जीवन ही खत्म हो जाता, 17 का हूंगा शायद, तो मेरा तो जीवन ही खत्म हो जाता। तो उस दिन से मैंने समझ में आया कि नहीं यार, हम शिफ्ट कर ले साइबर सिक्योरिटी की तरफ। सिक्योरिटी की तरफ इसलिए क्योंकि आज हर आदमी परेशान है। आज हर आदमी परेशान है, मतलब आज हम इनसे परेशान नहीं है। ये जो चेहरे आप स्क्रीन पे देख रहे हैं, हम कतई इनसे परेशान नहीं। दुनिया के सबसे बड़े बड़े आतंकी चेहरे हैं जो मैंने स्क्रीन पे लगा रखे हैं। मुझे नहीं पता आप में से इनमें से कौन किस किस को जानता है, लेकिन ये सब बड़े बड़े आतंकी चेहरे, ये तो खत्म ही हो गए भाई साहब अब। तो ये टेंशन का विषय नहीं है अब हमारे। टेंशन का विषय क्या है? सपोज लाइक से आप जितने लोग यहाँ पे भी कॉन्फ्रेंस अटेंड कर रहे हैं, आई जस्ट प्ले स्मॉल ट्रिक विथ यू एंड मैंने आपके अकाउंट से किसी तरह से 1,000 रुपए निकाल लिए, सपोज 1,000 रुपए निकाल लिए आपके अकाउंट से, और ऐसा काम मेरे को सिर्फ 100 बैंक अकाउंटों के साथ करना है। सिर्फ 100 बैंक अकाउंट से मेरे को 1,000 रुपए निकालने हैं, और मेरे को जाके जो हमारे नेशनल टेलीविजन हैं इनको बताना है कि साहब ये 100 लोग हैं जिनके अकाउंट से पैसा निकल गया। क्या होगा? उसके बाद अराजकता फैलेगी कि ये 100 लोगों के अकाउंट से पैसा हैक हो गया। हो सकता है वो जान करके निकला हो सकता है वो गलती से निकला हो, धोखे से निकला हो। लेकिन आप सोचिए कि पब्लिक आज 2 महीने के लॉकडाउन के बाद शांत बैठी हुई है। पब्लिक 2 महीने के लॉकडाउन को समझ रही है और गवर्नमेंट का साथ दे रही है। लेकिन जहां मेरे अकाउंट से 1,000 रुपए निकला, मेरे को लाखों रुपए का लॉस हो गया, घर में बैठ के चलेगा। लेकिन जहां मेरे अकाउंट से 1,000 रुपए निकला, मैं एकदम से ये जो है मास मूवमेंट में कन्वर्ट हो जाएगा, और आप देखिए अराजकता कैसे फैलती है। तो सिर्फ हमें एक छोटी सी चिंगारी फैलानी है, और इट इज वेरी इजी नाउ डेज। मतलब ये कुछ मेरे पास मीडिया है जो आप मेरी स्क्रीन पे देख रहे हैं, फेसबुक, इंस्टाग्राम, स्टूडेंट्स बहुत ज्यादा इंस्टाग्राम पर एक्टिव है। बस मेरे को थोड़ा सा एक चिंगारी फैलानी है और एकदम से आग लग जाएगी। तो मुझे नहीं लगता कि ये जो टेररिस्ट है ये हमारे लिए कोई बड़ा खतरा है। आज आज पूरी दुनिया में जिधर देखो उधर एकदम लाशें बिछी हुई हैं। क्या किसी ने आतंकवादी हमला किया? नहीं। दिस इज जस्ट द यूज ऑफ बायोटेक्नोलॉजी। अंडरस्टैंड? टेक्नोलॉजी, बायोटेक्नोलॉजी। हमने बायोलॉजी और टेक्नोलॉजी को मिक्स कर दिया। एक वायरस बना, वो वायरस दुनिया में तबाही मचा रहा है। कोई आतंकवादी हमला नहीं हुआ। जितना आज तक ओसामा बिन लादेन ने लोगों को नहीं मारा होगा, उतना ये वायरस तो मार चुका है। तो आप समझिए ना कितना डेंजरस है ये। हम टेक्नोलॉजी में काम करते हैं, तो टेक्नोलॉजी पॉजिटिव यूज भी है, नेगेटिव यूज भी है। और साइबर मीन्स एंड वेज से तो ये बहुत तेजी से स्प्रेड होता है। मतलब आप में से कोई है क्या, मैं अगर आप में से कोई अपना हाथ उठा के बताना चाहेगा, आप में से कोई ऐसा है जिनके साथ कभी इस टाइप का हुआ हो कि उनको एक मेल आया हो? मेल क्या आया हो कि अटेंशन मिस्टर हेमराज, योर पासवर्ड इज दिस। अभी पिछले 1 महीने में किसी के पास ऐसा कोई मेल आया क्या? अगर आप लोग शायद बात नहीं कर सकते हो तो
नो सर, ऐसा कोई भी मेल नहीं हुआ है।
नहीं हुआ ऐसा कोई भी मेल, है ना? सो मैं आपको लाइव दिखाता हूँ, लाइव फेसबुक पे। आपको मेरी स्क्रीन दिख रही होगी? आपको मेरी स्क्रीन दिख रही होगी? मेरे बहुत ही स्लो है, बहुत ही स्लो है। मैं आपको लाइव दिखाने की कोशिश कर रहा हूँ कि क्या न्यूज़ थी वो। बहुत नीचे चला गया, मेरे को लगता है कि मैंने ज़्यादा पोस्ट कर दिए हैं। नहीं, नहीं, आप ये देखिए, ये किसी ने मेरे को टैग किया है, तो ये किसी ने मेरे को टैग किया है, आप ये वाला पोस्ट पढ़िएगा। CAJ चावला के साथ ही ऐसा फ्रॉड हुआ था। इनके साथ कोई उनका फैमिली वाला बन के सोशल इंजीनियरिंग कर रहा है यहाँ पे, उनके साथ कोई फैमिली वाला बन के उनको हैक करने की कोशिश कर रहा है, उनकी भाभी बन के उनको बोला कि भैया मुझे एक बहुत अर्जेंट काम है। बोले क्या काम है? मेरे को 10,000 रुपए भेजो, बहुत अर्जेंट काम है, किसी को बताना हो तो प्लीज अपने भैया को तो बताना ही मत। तो देवर है तो देवर को लगेगा नहीं यार शायद कुछ गड़बड़ होगी, इस वजह से कुछ कहा होगा, जो भी होगा। तो उन्होंने, देवर जी ने कोशिश की कि मैं पैसे ट्रांसफर कर दूं, लेकिन पैसे ट्रांसफर करने से पहले उन्होंने जो है सोचा एक बार कि क्या ये सही होगा। हम दोनों बहुत पुराने फ्रेंड्स हैं। उन्होंने मेरे से पूछा कि ऐसा होगा, मैंने कहा एक बार आप भाभी को फोन कर लो ना, इसमें टेंशन क्या है? हाँ, बोले भाभी पैसे मांग रही है ना, कोई और तो मांग नहीं रहा। बोले हाँ, तो मैंने कहा भाभी को फोन लगाओ। तो आप देखिए, वो एक अलग न्यूज थी, ये एक दूसरी न्यूज है। ब्लैकमेलिंग के मैसेज से यूजर सकते में, मतलब मैं अगर अभी इस ट्रेनिंग में आप में से किसी का नाम लूं, लाइक अखिलेश, अमन कुशवाहा, अमन आप अनम्यूट कर सकते हैं क्या अपने आप को? नहीं कर सकते। सो मैं कर सकता हूँ क्या आपको अनम्यूट? नहीं, ये मैं चैट कर पाऊंगा आपसे। नहीं, मैं होस्ट नहीं बना हूं अभी, मेरे को ऐसा लगता है अभी तक, क्योंकि मैं जब होस्ट क्लेम करने की कोशिश कर रहा हूं तो मेरे को होस्ट के लिए पासवर्ड मांग रहा है, अगर बुशरा मैम यहाँ पे हो तो। जी अमन, अमन आपको अगर एक मेल आए जिसमें आपका